Hello, everyone. My name is Ross Signal with Dranetz Technologies. Thank you for joining us this morning. I am joined online this morning by Thurman Bridgers and Ken DeMario from our technical support group. We thank you again for joining us today. Let's get into our agenda for this morning's presentation. I'm joined by Ken DeMario and Thurman Bridgers. We are actually remote today, so I will be doing the lion's share of the presentation just to avoid any technical conflicts going back and forth. But please chat up any questions that you may have during our presentation today. We are dividing our discussions today into our three topics that we had listed in our agenda. We're going to start off with IEEE 519 2014 compliance testing using our HDPQ family, followed by VFD monitoring, followed by HDPQ DC circuit monitoring for the HDPQ family. So it's a format that we did, I think, in our first presentation of the fall this year, except we're going to have three topics to discuss. So again, we're going to have a Q&A during each session. We're going to divide them again into three. By the end of each session, we will definitely get to all of your questions in regards to that specific topic. So please, during the session, please chat up any questions you have, chat them up to the entire group. We will either answer them during the session or we'll wait to the end of the individual session for that. And as usual, we will hang around at the end to answer any questions that you have regarding the three topics that we're talking about this morning, or certainly anything else regarding our Dranetz portfolio of products. Our next and last training, excuse me, for the fall of 2020 will be on December 9th. That'll be at 11 a.m. our same start time. And that will be a live tour of PQView and PQView DE. That will be a product presentation that will be done by Thurman Bridgers. And that'll cover the main aspects of the software, monitoring system, status and health, real-time metering, and going into the analytics and reporting of PQView and PQView DE. So if you have not registered yet for that session, please do using the same way you registered for today's session and all of our other ones. It'll be on that webpage. So without further ado, why don't we get started? And just as a reminder that, excuse me, as usual, we will be recording today's presentations. These will be three individual recordings that'll go on our webcast page on our website. We'll have that up by the end of the week. Usually it's by Thursday we have them up, but it'll be added to the library of presentations that we have available. So just first, for those of you who are new to us, just a little bit about Dranetz Technologies. We are located in Edison, New Jersey. You can see I'm circling where Edison is over here. We are a stone's throw away from Manhattan. We have a lot of people who visit us, or certainly prior to COVID, a lot of people visit us just to get an eye on Manhattan and tour Manhattan under the guise of visiting Dranetz. So very good location. Once COVID calms down a little bit, we certainly welcome you at our factory. I am actually at my home a little bit southwest of Dranetz right now, about a half an hour away. So Dranetz products and service portfolio, we manufacture three-phase power quality, demand, and energy instruments. These are portable instruments that you carry around. We have permanent versions of these, so permanently installed power quality, demand, and energy instruments, both products that have power quality, demand, and energy, and also those that are energy only in different price points and different capabilities. As for all of our products, each product range has analysis software that goes with it. We have our DrainView software for use for with our portable instruments, and we have our PQView and PQView DE software that works alongside our fixed versions of our products. We are owned by a company called Gauss & Metrowatt, a large instrumentation manufacturer based in Germany, Nuremberg, Germany, and we are the US and North American master distributor of their products. So you will see precision multimeters and testers, electrical safety testers, insulation testers, installation, and other types of testers. In addition to light meters, both photographic quality light meters and industrial quality light meters that we also distribute and sell, sold on the Gauss & Photo brand of products. Something that we're very proud of is our free technical support. Ken Thurman, and to a lesser extent myself, enjoy spending our day dealing directly with you, our customers, both in pre-sale and post-sale support. Um, our objective is that you choose the right instrument for your job, and then of course you understand how to use it, and we can answer any questions that you may have after the sale. We pride ourselves in our ability to get back to our customers, both however you contact us, via our website, via email, or certainly via phone. Um, we do offer remote on-site and, of course, remote training using Zoom and other tools today. This is training, this is paid for training on how to operate your products, whether that be a portable product or a fixed system. Again, our objective is to make sure that your system's up and running properly and that you and your users and your team know how to operate our products. So this is remote and on-site training, and this is tailored specifically for your application. Typically, this is anywhere from a day to several days, depending upon the size of your company and the size of your installation. We do pride ourselves on our website. Our website is, of course, not only a catalog for our products and our services, but it's also a library of information, not only about Dranetz products, but about the industry in general. We have application notes on standards and products that we offer for sale. And of course, as we've told you before, products designed by Dranetz are made in the USA, right in our factory in Edison, New Jersey. So we do design our products on the second floor, basically, and build them on the first floor. So we're very proud to say our products are made in the USA. Now, just to put a picture on the products that we offer, these are our portable products. You can see our HDPQ family, showing our Plus and our SP products. This is our new Dranetz product, which we introduced just a few months ago and started shipping in October. Here's our fixed systems of products, ranging from full-featured, very capable power quality meters to general purpose power quality and energy meters, down to energy-only meters. As I mentioned before, each product family comes with its own software. So for our fixed products, we have our PQView and our PQView DE software. And for our portal products, we also offer our DrainView software, which has been the mainstay of the industry for many, many years. As I mentioned, we are the US and North American master distributor of Gauss and Metrowatt products. And here's an example of some of their products, ranging from precision multimeters to safety testers to light and photography meters to machine testers and other types of meters. So basically, if you see a product in green, it's probably a Gauss and Metrowatt product. So why don't we get started here in the reason why we're all attending this morning's presentation. The first application that we're going to speak about is for the Dranetz HDPQ family, IEEE 519 2014 compliance testing. And we had a seminar in our last round that covered harmonics and harmonic standards. And this is kind of encompassed in that. And we're going to give a little review of the standards and the terminology involved in this, but we're going to also go into how to properly configure your Dranetz HDPQ family instrument for use in this particular application. So just as a review, the Harmonic Standards, there's a standard that's been around and in use for many years, certainly in Dranetz products since the mid-2000s or so, and that's called IEC 61000-4-7. And that is an international harmonic standard, and it's part of the IEC 61000-4-30 requirements. And if you're Class A compliant with 61000-4-30, you inherently comply with this 61000-4-7 standard. It is a substandard that specifically is focused on harmonics. Well, the IEEE in 2014 updated the IEEE 519 recommended practice to update on harmonics. And the harmonic computations were harmonized, or in other words, made the same as those in the IEC 61000-4-7. So what that meant for Dranetz is that, well, we've been measuring to this standard for many, many years, probably 10 years or so at that point in 2014. But the IEEE didn't stop there. They also added a couple customized parameters just for the IEEE version of the standard. So in addition to the measurement methods used for harmonics from the IEC 61000-4-7, IEEE 519/2014 added two important parameters and how to measure for the presence of harmonics. And this is in addition to the compliance limits and other things that were defined in 519/2014. And the first parameter is called very short time harmonics. And what that is harmonics are evaluated on a 3-second aggregation or calculation. Then there's I'll call it slower parameter called short time harmonics that are aggregated, an aggregation of the very short time into 10-minute harmonic computations. So IEEE 519/2014 added these two parameters, very short time and short time harmonics. And they also defined the limits and the statistical requirements to assess compliance to the requirements in 519/2014. So why are managing harmonics and why is 519/2014 so important? The first reason, if you're measuring in the United States, this is the current U.S. recommended practice for harmonics measurements and compliance, and it includes both voltage harmonics and current harmonics. However, this is also being applied outside the United States in Central America, Latin America, and South America, Asia, and other parts of the world. Some parts of the world merge various aspects of standards together. So this is certainly a US and North American thing, but this has become a requirement in other parts of the world, and hence the attendee list that we have in some of the regions of the world who are joining us this morning. Well, just in summary, the compliance limits are referenced at the point of common coupling between the utility and the end user. I'll skip over the applications for a second, but the intent is to manage the harmonics at the interface point between the utility and the system owner and the end users. So this is that point of common coupling. The specified limits are only at the point of common coupling, but they're not really intended for individual loads. They're often used that way, but this is meant to manage the relationship between the provider of electricity, the utility or the system owner, and the end user, and at that point of common coupling. However, a lot of applications take that into the facility and use these types of measurements at the terminals of a motor or a process or something like that. So again, it's only required and the standards are set up at that point of common coupling, but the owners of our products and the users of this recommended practice use it throughout facilities, typically. So there are compliance limits for voltage and there are compliance limits for current. For voltage, the recommended limits for individual harmonics and VTHD, which is voltage total harmonic distortion, are specified at the various bus levels measured at the point of common coupling. So the acceptable limits are based upon the bus voltage, with higher bus voltage voltages having lower acceptable limits. And really the method is, or the meaning behind this and the reason, the rationale is that what produces harmonics are the loads that we have in the system. And so those produce the harmonics, the generators, whether that be, a DER or something like that, or solar or gas-fired generator, they produce very pure sine waves. So it's the loads that we plug into the electrical system that produce the harmonics. So as we get closer to those loads, as the voltage goes down, as we're closer to the consumer of power, the acceptable limits have to go up a little bit because that's where these harmonics are originating from. But conversely, when you go up through our distribution systems and transmission systems, that's not where these harmonics are originating. So the higher voltages means you're farther up the system, closer to the generation, the lower the acceptable limits are, because really if you get harmonics, they reflect up to that point, it's more of a major problem because everyone has to deal with them in the system. So hopefully that was clear. Continuing on, there's also current recommended practices, and the recommended limits for individual current harmonics are also specified at the different voltage levels. So 519/2014 asks us to monitor the voltage and the current, and each has compliance limits based upon the distribution voltage that we're monitoring. However, for current, one of the changes in the 2014 version is that we're not looking at current THD, we're looking at total demand distortion. And TDD takes into account the overall capacity of the system. So we're not looking at individual THD, which is kind of, it doesn't reference the capacity of the system. We're looking at harmonics based upon what the overall capacity of the system. So a low amount of harmonics on a high capacity system are not really a big deal. But if you have high distortion and the amperage is high compared to the capacity of the system, well, that becomes more and more important. And that's the basis behind TDD. But again, voltage and current references are used based upon the bus voltage. And that's the big thing. So how are these measured by the instruments? And this is important because I don't want to get too technical here, but this goes into the ability of your instruments to produce this data. And that's why older instruments can't measure to these standards, because they don't have the computational requirements that are needed for 61000-4-7 and of course 519-2014. So as specified in 61000-4-7, what that says is that you measure a 200 millisecond window, and that's what's shown at the bottom over here. And that represents 12 AC cycles at 60 hertz and 10 AC cycles at 50 hertz. And the harmonics, and in fact, other measurements are computed on this 200 millisecond window. So the instrument doesn't look at one cycle, it looks at either 10 or 12 cycles, depending if you're operating at 50 or 60 hertz, okay? And the above is part of IEC 61000-4-30, Class A Edition 3. So it's been part of the standard for a while. We're not focusing on that standard, but it's all kind of wrapped together. But it's very important to note that these types of measurements, looking at 12 cycles or 200 milliseconds at a time, this does not apply to sags or dips or swells or transients. They are looked at on a cycle by cycle basis by the instruments, which is also required by 61000-4-30, certainly for sags and swells. 61000-4-30 does not define transients. So the higher speed, if I can call it, power quality events are looked at a cycle or sub-cycle detail, and these are for slower types of events, and of course harmonics falls within that category. So how do you set up your HDPQ family to do this? The good news is that certainly this applies to any product in the HDPQ family, whether that be the HDPQ Plus or SP, and all 4 model tiers. And what I mean is the Visa level, the Guide, the Explorer, and the Explorer 400. What we're going to discuss on setups applies exactly the same to all of those products. Again, whether it be a Plus or an SP instrument configuration. And the good news is that the instrument basically does all the work for you. You just have to set up a couple things. And so we're going to give you a couple slides here on those setups, but I'm going to also go through an online demonstration on how to do that, as well as followed by some data that's been recorded, and we'll show how that's reported in DrainView. So the first thing here is to set the monitoring mode to standard power quality IEEE, and that keys the instrument to do things the IEEE way. And there's another one for IEC, which does not enable this reporting. So if you're in Europe or other parts of the world that follow the IEC monitoring, we would suggest that. And that would be standard power quality monitoring for IEC. So we're going to choose IEEE here. And the anything 519-2014, as far as configurations, that's done automatically by the instrument. So you don't have to worry about anything. The instrument does everything for you as far as the configurations. The only other thing that you might want to consider is to select the weekly report start date and choose the day after the monitoring starts. And what we mean by that is that, today is Wednesday. If I start monitoring today, I want to choose Thursday as the start of my reporting. And the reason why we suggest to do that is that you get a full day to start. So if I started today, it's 11:20 in the morning here, I wouldn't get a full day on Wednesday. So unless there's an overriding need to start today, start tomorrow, so you get a full day on your first day. But you also have to monitor for a complete week after that, as per the 519-2014 requirements. So just to note, use the default harmonic current intervals. the instrument sets itself up to a 10-minute journal interval for harmonics. That is the instrument default. You, of course, can change that, but this is part of the short time harmonic assessment that's required by 5/19/2014. So this is kind of hands off. You really don't have to touch anything else in the instrument. It's going to set itself up to do all the statistical analysis and the recording for the harmonics, as well as the reporting for the harmonics, which includes how often the instrument records to memory, which is those journal intervals. So you don't have to do anything. And again, as I mentioned before, monitor for at least 1 week, because the requirements in 5/19/2014 is for short time harmonics. Those are assessed over a 7-day or 1 week period. The very short time harmonics are assessed each day. So you'll get in my example, if we start tomorrow, you'll get Thursday, Friday, Saturday, Sunday, and so forth. But those are also assessed over a weekly period as well. So the minimum reporting period or recording period should be 1 week. Okay, you guys can do whatever you want, but to get a full report for 5/19/2014, you should record for at least 1 week. But if you keep the instrument recording for, let's say, a month, you'll get 4 of these intervals, 1 for each week of the month. And then you'll have daily reports for very short time harmonics for each of the 7 days during that week. All right. And again, as I said before, and I just said, the HDPQ Plus and the SP, well, that does everything automatically for you. There's nothing else that you need to do. So why don't I share another screen? And this is actually using our instrument simulator. Unfortunately, I don't have remote access to an instrument right now.
Hey,
So
Ross, if
yeah,
you would like, if you want to take a break, I do have access to an instrument. I can sort of take you through a quick tour of the setup to show just how straightforward it is.
yeah, sure. Go ahead,
Okay,
Thurman.
if you will allow me to give me grants to share the screen, I should have it now, right?
Yep,
Nope.
just bear with me a
Okay.
second. Hang on.
All right.
I gotta stop sharing here.
All right. Thank you.
You have it now?
Yeah, going to it now.
Okay.
Yeah.
Thank you.
And
Thurman, while you're doing that, I'll read through the chat so we can address them at the end.
All right. Thank you, Ross. So what Ross and good morning, good afternoon, good evening, wherever you are globally. I'm Thurman Bridges, as Ross mentioned earlier. So, thank you for attending. And what I'd like to do, and that was very informative, what Ross presented, but let's put it into practical terms as far as setting up an instrument. And one of the benefits of HDPQ is that it requires to be compliant with the 5/19/2014 standard. It requires very little user input from the instrument, and the instrument is doing the lion's share of the work. And so in this example here, we have, and hopefully everyone can see the display here, this is actually a live instrument that one of multiple instruments that we have on, as Ross mentioned earlier, point of common coupling, where the customer meets a utility. This particular instrument is set up in what we call our 2-probe delta config. So the numbers here is not really important for this particular exercise, but mainly the setup and the approach that you would take for 5/19. So obviously you begin your monitoring session by start monitoring. And those of you that have used HDPQ before, you're probably familiar with this screen where you're basically choosing one of many monitoring approaches here. And the approach is what we call, you can use the automatic, but what I would suggest, and Ken, my colleague, can probably chime in as well, is what we call the widget setup. So the widget setup gives you more flexibility as far as setting up the instrument. And there's a couple of things that you want to be aware of, especially if you're going to be fully compliant with 5/19/2014. As Ross mentioned earlier, there's VTHD, and then there's TDD, which is total demand distortion. Voltage harmonic distortion is pretty straightforward. It's usually referenced to the fundamental, or might be referenced to RMS, depending on what the application is. In 2014, it's usually referenced to the fundamental. Total demand distortion, TDD, is referenced to your maximum demand current. So because there is no ITHD in the standard, as Ross mentioned earlier, is reference to demand current. So if your compliance is going to involve TDD, then there's some things that you need to be aware of in the setup. But the approach, as far as probes and scaling, that's pretty straightforward. This is where you're telling the instrument as far as the current probes that you're using. Of course, there are a number of different current probes. As you can see here, it's a little bit slow, but it'll eventually load. So you can see the various different current probes that you can use. If you're using turns ratio, that's important if you're involved in medium and high voltage applications, where obviously you can't bring those values directly to the instrument. In those applications, you usually piggyback off existing PTs. The wiring config, and this is where you tell the instrument the type of circuit that you're connected to, whether it's ranging from single phase to split phase, or the more common industry standards such as delta and Y configurations. So that's fairly straightforward. The instrument by default is going to try to auto detect, but you have the ability to override that and make sure you have the correct circuit configuration selected. The first place in which it's going to require the user input. And again, especially if you're doing TDD, because TDD is based on a ratio of what we call the short circuit current here to the max demand current. Now, the short circuit current is usually provided by the utility. If you don't already know that, the max demand current, how it's usually calculated, you take the peak demand current over 12 consecutive months and you determine the average. So by putting these two key pieces of information here, the instrument knows what is called the short circuit to demand current ratio, and that is key as far as making sure that you have the limits selected. And then the other, as Ross mentioned earlier, as far as the monitoring mode, there's two things here. You want to choose standard power quality. You don't have to go into any of these other customized templates. So you're going to choose standard power quality. And then when you want the compliance to start. Today is Wednesday. So obviously I want it to begin on a Thursday. That is what we recommend. So from Thursday to Thursday, it's going to give you the weekly compliance. Daily, Thursday to Friday will give you the daily compliance. And then really there's nothing else that you have to do at this point. Everything else is pretty much the defaults. When you go through you don't have to do anything here. And then the next step is finalizing. And the only thing that you might want to do here is give the monitoring session a unique name. Instead of using the standard, the default of HDPQ, you might want to give it a different name to better organize the files when you're viewing the data in post. And then it's just the start monitoring, initiate monitoring. And you accept the changes. And now the instrument is off. You've begun the monitoring session. One of the questions that came up is, how long do I monitor? Well, really, the longer the better, as far as making sure that you're compliant, because if you're trying to because changes can happen daily, you can have these swings of these valleys, what I call peaks and valleys, doing daily monitoring. So a longer monitoring period will give you a better picture as far as your compliance. So as you see, as Ross presented, theoretically, you can see practically it's really very little user input that you have to put into the instrument to achieve that. So that concludes my quick tour of that. And Ross has some examples, some post data that he wants to show you as far as what the results are.
All right, great, Thurman. Thank you. If you could just stop sharing so I can just share
I'll
this.
do that. So it's now, you
Okay.
should now have the floor now.
Just bear with me a second. All right. hopefully you folks can see DrainView here. So thank you, Thurman. Nice job. As Thurman mentioned before, very easy to set up the instrument to do so. Just a couple key things. And the resultant data, and we'll address some of the chatted questions here. The resultant data is recorded into your instrument database, which is of course transferred into DrainView. However you get the data into DrainView, whether you remotely control and you download the data directly from the instrument using a network, or you use a sneaker net with a jump drive. Once you get the data in DrainView, you have the ability to do everything DrainView can do. And that means you can plot any parameter, do anything you normally do, but what DrainView will show you is, which is what exactly is in the instrument, which you can see in the instrument as well, is each of the reports produced. And that is 2 weekly reports, or actually 3 weekly reports, and a daily report for very short time harmonics. And you can see one highlighted here in the event list. And if you look on the right, this report is done in a pass-fail format. And the statistical analysis engine of HDPQ, and all this is done in the instrument. You are viewing recorded data here in DrainView. So there's no post-processing done in DrainView other than potentially creating a report for a printout and a Word version of your report. So this is a pass-fail report, and this is the very short time harmonic report, and you can see the date, it's just a few years ago, and this is a pass report. And so the statistical engine of the instrument looks at the nominal voltage, and it looks up in a table in accordance with the standard and says, well, these are the compliance limits. And then of course it compares the limits to the measurements made by the instrument, and then gives you a pass or a fail. You can see these are all pass. These are all the real time measurements done at that time, or the statistical measurements done by the instrument for both voltage and current on each of the 3 voltage and 3 current channels. And it'll give you the pass-fail results. So if I look down here and I select one of the ones towards the bottom, this is a fail report for a very short time harmonic. And it's failing because of the THD, and these individual harmonics for voltage were out of the whatever required limits. And these are actually quite high for this particular application. Voltage harmonics, the allowable limits are certainly below 10%, 5-8%, something like that, depending upon the bus voltage. So you can see how DrainView produces this information, which is basically just displaying this for you from the instruments. You'll see something very similar in the instrument itself. You can use the DrainView report writer. If I just click Start, and you can see the report writer, and I just do a custom report. I click OK. And you can see I have selected IEEE 519 harmonic statistics. You can select other things here. There's a wealth of data and reporting templates available for you, but I just have that one report type available. And if I click Finish, it's going to create a report for me summarizing all of that information. So you can see, and now I can export this to a Word or an RTF or any other format that I like. And once I get it into Word or an editor, I can put my logo on it. I can customize it any way I want. And here's a summary for the entire reporting period, and which reports passed, which reports failed. And then below each report, each weekly report, individual report, and the details of each daily report that has been done. So I'm just scrolling through here just to give you a snapshot of it. But this is actually putting together in one file everything that we showed to you before that can be reviewed on the instrument or within the DrainView software. So it's quite easy to do. So anyway, that's all. That's it for this particular module. Let's just go review the chats that we have discussed here. And I'll just start top down. And we have a comment from Israel, from Amir, and that they are following the 519 and it's mandatory over there. So Amir, thank you so much for that. And India as well. Sachin, hopefully I pronounced that right. I apologize if I didn't. In India, as mentioned, that they will follow 519-2014. That I happen to be aware of because we're doing some business in India as well. So Seth Kumar asks or says that 519-2014 informs daily 3-second and weekly 10-minute intervals and measurements, and goes through a summary of the samples and asks, how do we evaluate that? And the way the instrument does it is that it maintains all the statistical data within the instrument itself. And as I mentioned before, the instrument reports based upon the requirements of 519-2014. It does not record all those details to the database. In other words, all the 3-second data, it doesn't record that. It records the 10-minute intervals because that's just a regular journal interval by the HDPQ family. But unless you set the journal interval for 3 seconds, which I do not recommend that you do, certainly it's not needed for this application. So unless you do that, you are not going to get those 3-second data, that data in the database. Because there's no need for it. The instrument maintains all the statistical analysis, and products that do things like that, the reason why they do it is because they can't maintain that statistical data. That has to be done offline in a spreadsheet or using some other math engines to do that for you. But the HDPQ family does this automatically for you in the background right while you're monitoring. You don't have to do a thing. In fact, of course, we didn't mention it before. This can be just a regular PQ survey that includes the harmonic calculations in the background. So you could be looking for dips and swells and transients and everything else the HDPQ can do at that time. So William says their customers were amazed. They got the Power FFT from the DrainView demonstration. That's fantastic. Thank you for that positive feedback, William. Sachin asks, if a utility wants to impose penalties, then ideally how should they do it? Well, that's certainly up to the utility. We're not ones to do that, but the instrument provides the daily and the weekly. So my guess is a utility will provide feedback and provide requirements if they're going to instill requirements based upon both daily and weekly. Because you could have a case if you have one real bad day or a couple real bad days that maybe get averaged out over an entire week. So your weekly aggregation may be within limits, but daily aggregations may not be because you have maybe some very distorted loads that turn on temporarily. So there's opportunities to game the system. So my thought would be a utilities that's going to impose requirements would be on daily and weekly information because that's the recommended practices from the IEEE. So Seth Kumar says instruments have recording vacancies due to power quality issues and supply. How does Dranetz maintain the sample size? Again, we are doing the statistical summary within the instrument itself. So we don't consume the database, the recording database for this other than reporting on the daily and the weekly requirements for the recommended practices of IEEE. So that doesn't really consume much. It's maintained in the volatile memory, let's call it, of the instrument. All the data is maintained there. So it's not streamed to your recording database, so you don't get that burden of that. And Amir asks, he has 2 questions. Can we compare IEEE and IEC at the same time? Reporting wise, there's probably a little bit of a conflict there. Certainly, and maybe Ken or Thurman can chime in, I don't believe that EN 5160 reporting can be enabled at the same time as if you don't choose that mode.
No, I don't believe it. I don't believe it does.
Yeah, I don't believe it can either.
Okay. All right. Perfect, guys. Thank you. So what that means is that, usually within a geographic region to date, there hasn't been a requirement to do both. It's been either or, and the instruments are set up for that. That being said, DrainView can do some post-processing and produce an EN 5160 report, but the instrument cannot do that. Both EN 5160 and the IEC and the IEEE simultaneously. And it's important to note for other things on the IEC and the IEEE, one of the reasons why we have those 2 monitoring modes is that each of them has slightly different settings when it comes to limits for interruptions and things like that. So that's the reason for that. So, and William asks, does the newer version of DrainView you're using work with the 4400? Yes, of course. We try to maintain downward compatibility, excuse me, on our software updates. So the 4400 is our power guide, which is the prior generation to the HDPQs. We go back to, in fact, I think our 4300 from the mid to late 1990s in DrainView, and even our 658, which even predates that. So that's a long-winded yes, William. And Michael asked, what is the recommended accuracy for the max short circuit current?
I'll take that, Ross.
Okay, good.
Let me answer that. The max short circuit current information that is provided by the utility. So either you know it or you get that information from the utility. And then yes, that information is entered from the the screen that I showed you, where you would enter what we call the max demand current and the max short circuit current. And then the instrument has what it's need, because remember, your TDD limits are basically set based upon that ratio, which is the short circuit current to max demand current. So yeah, so that information you would need to have. Usually it's applied by the utility, and then the second answer is yes, that information is entered into the instrument during the setup.
Okay, great. Thank you, Thurman. And by the way, our DRAN expert, and certainly HDPQ can do this, but our DRAN expert can do this as well, is to basically do the load survey for that short circuit current and look at that maximum demand over the period of time that you do
That's
that.
correct.
And that applies to partially to Tony's question, any plans to include the mill standard 1399 for shipboard power. We've had that asked before, and quite candidly, Tony, I'd have to take another look, but I think there were some other things that were beyond standard power monitoring in there. So we can do some of the measurements for mill standard 1399, but we do not have a compliance report for that. But we are keeping an eye on that and some of the other standards out there. So Amir says, I apologize, Amir, that I skipped the second question, but I think that was addressed based upon what we talked about before. And how do you get the current load? Do we make a 1-year measurement? And the 1-year measurement you'd probably get from your utility meter reading, readings and in your energy reports and things like that. But the Thurman's report, to thought before, you can do these measurements over a shorter period of time. You're allowed to do that. And Thawisak asks, we're using HDPQ Explorer Plus. They have a question about its application. Is it possible to trigger on current direction when current direction is changed? And I think you mean changing current flow.
Right. That's, yeah.
I think that would change the direction from positive to negative and negative to positive, but I'm not quite sure if you can trigger on that. I don't know if Ken and Thurman know.
No, we don't know. We don't assign a sign for
there's
current.
No polarity to that.
There's
right?
no polarity sign. The way you typically determine, and what Ross just stated, it's basically all to do about flow. If you have reverse flow, and typically the way we do it in our instruments is the sign of power, active power. Negative, if negative usually means reverse flow. If your CTs are oriented on the circuit correctly, positive usually means that you have normal flow from source to load.
Yeah, and as William mentions, you'd move the quadrants. That wouldn't be triggerable on the current per se,
right?
But there may be an application in triggering on the phase angles. So I won't say that's a hard no. It's a hard no, I think, using current as the trigger, but I bet you that there's ways of doing that, maybe on the direction of power flow.
You could actually do it using with forward and reverse energy.
Yeah, true.
You could, but that's only in the Explorer.
Yes.
So, you can set a limit on either one of them when they get a certain point, and you can notice when they hit that point.
Sure. Okay. All right. Thank you, Ken. That makes sense. So, okay. So we're going to wrap up this particular session here on the 5/19/2014. So I'm going to actually stop recording and start recording again for our next session on VFD monitoring. And of course, we'll address any other questions towards the end. So just bear with me for 1 second here.